All right, today we're going to take a look at what we call polynomials. And a polynomial is a monomial or the sum of monomials. Now, as I use the terminology monomial, let's go back and refresh our memory of what a monomial is. A monomial has one term. Terms are separated by either addition or subtraction symbols. So, some examples of what a monomial may look like. A monomial may be just a number. A monomial could be the product of a number and a variable, or it could be the product of variables. Or I could write, all of these are examples of monomials, okay? And if you recall, we've talked about a binomial before, and a binomial has two terms. Examples, I could have x plus 5. I have two terms. They're separated by an addition symbol. I could have m minus n. Two terms. They're separated by a subtraction symbol. So in the first part of our lesson today, we're going to look at a polynomial and identify what we call the terms and identify the numerical coefficients, okay? So if I gave you a negative 3x squared plus 5x minus 6, well, that is a trinomial. This has three terms. I'm going to look at each term and identify. I'm going to look at this term. I have a negative 3x. That's my term. Then I want to look at what we call the coefficient. Remember, the number before the variable is called the coefficient, or we call it numerical coefficient. So the coefficient there is a negative 3 is the coefficient. If I look at that 5x, the coefficient for the 5x is a 5. So we need to be able to identify coefficients, because as we get to our next lesson, we're going to be combining like terms, and in order to do that, you would need to know what your coefficients are. So at this problem, if I gave you a negative 5x to the 4th minus 9x squared plus 6x. Well, in this problem, I have three terms. This is a term, this is a term, this is a term. The coefficient here is a negative 5. Coefficient here is a negative 1. And the coefficient here is a 6. Now, we're not only going to be able to identify coefficients and terms, we're going to look at the polynomials and find what we call the degree. If I wanted the degree of a monomial, suppose I had the monomial 6x squared. To find the degree is the sum of the exponents. Well, I only have one exponent there, and that exponent is a 2. So the degree for this particular monomial, it has degree of 2. If I had a negative 7x to the 3rd, y to the 2nd, well, that is one term. To get the degree, I'm going to add these exponents. So the degree for this particular monomial is 5. It has degree 5, okay? So to find the degree of just a monomial, it is the sum of the exponents, the sum of the exponents. So let's see what happens when I have a polynomial. So let's look at x squared plus x minus 6. Let's determine if this is a monomial, a binomial, or a trinomial first of all. Well, I have three terms here, so that means I have a trinomial. Now I need to find the degree. To find the degree of this trinomial, I need to look at the degree of each term first. The degree of this term is a 2. The degree of this term, there's an exponent there. You don't see it. It's understood to be a 1. So the degree of this term is a 1. This is called a constant term, and the degree of a constant term is 0. Now, once you determine the degree of each one of the terms, then the greatest degree that you see is the degree for the polynomial itself. So the greatest number I see is 2. So that means that this polynomial has a degree of 2. If I had 3x plus 10, I have 2 terms, so this is called a binomial. Then as I look at the degree for this term is a 0. The greatest number that I've written down is a 1. So the degree for that particular binomial happens to be a 1. If I had 10, x to the third, y to the second, z. Well, that's only one term. It's one term because you don't see any addition or subtraction symbols, okay? So that means that I have a monomial. And when I get ready to get the degree, I'm going to add these exponents. I see 3 plus 2, which is 5, plus 1, which is 6. So that means that this monomial has degree of 6. In the next part of the lesson, we're going to evaluate some polynomials, okay? So let's evaluate when y equals 0 and y equals a negative 4. I'm sorry, let's change that to a negative 2. So as we look at these examples, let's say example A. If I had 4y minus 7. Well, the first thing I need to do is evaluate this where y is equal to 0. So where I see y, I'm going to put a 0. 4y means to multiply. So that would be 4 times 0 minus 7. 4 times 0 is 0. And 0 minus 7 gives you a negative 7. Then I'm going to do a part B, where I'm going to let y be a negative 2. So again, I'll take 4y minus 7. Again, 4y means to multiply. So that's 4 times a negative 2. 4 times a negative 2 is a negative 8. And a negative 8 minus 7, that is where that chapter 1 is so important that you will remember our rules for addition and subtraction. A negative 8 minus 7 gives us a negative 15. So you will have to do some evaluating of polynomials in this particular section also. Now as we simplify some polynomials. So let's simplify. If we had 3x minus 10x. Well, first of all, they have to be like terms in order for us to be able to simplify. These are like terms because they have the same variable x and the x has the same exponent of 1. So look at the numerical coefficients. I have 3 minus 10. 3 minus 10 is a negative 7. So 3x minus 10x will give me a negative 7x. If I had 3y cubed minus 6x squared plus 2x squared minus 5y cubed. Now we need to look at this problem and see, do we have any like terms? Yes, we do. This 3y cubed has a like term of a negative 5y cubed. So I'll do 3 minus 5, and 3 minus 5 is a negative 2, so I'll get a negative 2y cubed. Then as I look at the x squared, the negative 6x squared also has a like term, it's 2x squared. As I combine the numerical coefficients, I have a negative 6, I have a positive 2. When I combine, I get a negative 4. So I have a negative 4x squared. And as I read my answer, it is read as a negative 2y cubed minus 4x squared. And after we simplify, so we're going to identify, in the next set of instructions, we're going to identify the degree of the terms and the degree of the polynomial. So the instructions: identify the degree of the terms and the degree of the polynomial. So if I gave you 2xy minus 5x plus 6xy. So these instructions are telling me to give the degree of each term. The degree of this term, add the exponents. 1 plus 1 is 2. The degree of this term, I only see a 1 there, so the degree of that one is 1. The degree of this is 2. The greatest number that I see there is 2. So the degree for this polynomial is the degree of 2. If I had x cubed y minus x squared y squared plus xy cubed. Well, as I look at this first term, add the exponents. 3 plus 1 is 4. The degree for here, 2 plus 2 is 4. The degree here, 1 plus 3 is 4. And the greatest number I see is 4, so the degree for this particular polynomial is 4. And sometimes you will be asked to write polynomials in order with no missing terms, okay? So if I want to write the polynomial, I want to write this with descending powers with no missing terms. So that means descending, that means you start with the greatest exponent. So when I rewrite that, it'll be a 5x cubed. I don't see an x to the second. So if you take 0 and add 0 to something, that doesn't take away from anything with the problem. So I'm going to add a 0x squared. I'm letting this decrease. I don't see an x to the first, so I'll have a 0x, then plus 3. Now this is going to be extremely important when we start dividing polynomials. Sometimes you'll have missing terms, and we'll be able to insert what we call zeros, okay? If I had a negative 8 minus x squared plus 2x cubed, I want to write this with descending powers. I will start with the greatest exponent for x. The next exponent would be x squared. Now I don't see an x to the first, so I'm going to insert a 0x minus 8. So that takes care of section 5.3 in this particular chapter. Now we're going to look at section 5.4, where we're going to add and subtract polynomials, okay? So we're adding and subtracting. Polynomials. Example 1. If I had the binomial 6x plus 11 plus the binomial 4x minus 5. The first thing I need to do is find my like terms. 6x has a like term. Its like term is 4x. So I'll add the numerical coefficient. 6 plus 4 gives me 10, so I'll get a 10x. As I look at the constant terms, that's a positive 11. That dash makes that 5 negative, okay? So if I combine a positive 11 and a negative 5, I get a positive 6, so I'll put plus 6. The answer is 10x plus 6. If I had the binomial 4x minus 7 plus the binomial 3x squared minus 5x plus 9. And as we write the answers, we're going to write them in what we call standard form, starting with the greatest exponent for the variable and let it descend. So I do not see a like term for the 3x squared, so I'll just keep my 3x squared. I notice I have a positive 4x, I have a negative 5x. If you take a positive 4 and combine a negative 5, you get a negative 1, so I'll have a negative 1x. That dash makes the 7 negative. I have a negative 7 plus 9. When I combine, I get a positive 2. Example 3. Sometimes these problems are written in what we call horizontal form. Sometimes they will be written in what we call vertical form. And the good thing about vertical form is the like terms are already lined up for you. And all you have to do is combine. So this is called vertical. This is called horizontal. This is called vertical. In vertical form, the like terms are already lined up. So I am adding, I want you to know I'm adding 4a squared plus 1a squared. 4 plus 1 gives me 5, so I get 5a squared. A negative 2a, and I want to combine a positive 3a to it. I end up with a positive 1a. And then I have a positive 15 and a negative 11, and when I combine, I get a positive 4. So my answer is read as 5a squared plus a plus 4. Example 4. If I had 12y plus 8 minus a negative 2y minus 4. Now, when it is written in horizontal form, I highly suggest that you clear the parentheses first, okay? Well, everything in the first set of parentheses is going to remain the same. If you recall, you have been taught that anytime you have a dash before the parentheses, all you have to do is take the opposite of what's inside. Also, the rule for subtraction is to subtract a number, add its opposite. So the opposite of a negative 2y becomes a positive 2y, and the opposite of a negative 4 becomes a positive 4. After you've cleared the parentheses, then collect your like terms. I see 12y plus 2y, and 12y plus 2y gives me 14y, and 8 plus 4 gives me 12. Example 5. If I had the binomial of negative 1x squared plus 3 minus the binomial x squared minus 4 plus the trinomial 3x squared minus 4x minus 9. Well, the first thing I'm going to do is clear the parentheses for this part because I'm doing subtraction. First set of parentheses remains the same. The opposite of 1x squared is a negative 1x squared. The opposite of a negative 4 is a positive 4. Now I'm going to combine that, and then I'll come back and combine the like terms with that trinomial. I see a negative 1x squared plus a negative 1x squared. A negative 1 plus a negative 1 gives me a negative 2. So that's a negative 2x squared. 3 plus 4 gives me 7. And I'm going to add to it that 3x squared minus 4x minus 9. I see a negative 2x squared and a positive 3x squared, so that gives me 1x squared. I don't see a like term. There's not a like term for the negative 4x, so I'll just write negative 4x. And then a positive 7 minus 9 gives me a negative 2. So the answer is x squared minus 4x minus 2. On example 5, sometimes the problems are written in words for you, such as it may say, subtract the binomial 2y minus 15 from the trinomial 3y squared minus 4y minus 8. Now, you've got to make sure that you know how to set the problem up. Again, it's asking you to subtract this binomial from this trinomial. So that means it is asking you to do 3y squared minus 4y minus 8 and subtract this binomial from it. Again, we're going to clear the parentheses. I get 3y squared minus 4y minus 8. The opposite of 2y is a negative 2y. The opposite of a negative 15 is a positive 15. And as I combine like terms, there isn't a like term for the 3y squared, so I'll keep my 3y squared. There's a dash in front of the 4y, a dash in front of the 2y. So I'm combining a negative 4 and a negative 2, and that gives me a negative 6, so I get a negative 6y. This 8 is negative, the 15 is positive. When I combine, I get a positive 7. And sometimes these will be written in vertical form, and you may have a problem such as 9x squared minus 8x minus 15. You may add 6x squared plus 7x minus 9. And I want to subtract, okay? I'm subtracting this. So I'm going to speak it as I subtract, and then I'll come back and show you how you can change the signs. 9x squared minus 6x squared gives me 3x squared. This is what I just did. I did 9x squared minus 3x squared, minus 6x squared, sorry. Then I'm going to do a negative 8x minus 7x, negative 8x minus 7x. That's going to give me a negative 15x. What I just did was a negative 8x minus 7x. That is how I got the negative 15x. Then I have a negative 15 minus a negative 9. That gives me a negative 6. I just did a negative 15 minus a negative 9. Remember, that becomes a negative 15 plus 9, and that is how we got that negative 6. For these two sections, the last part of it, you're adding and subtracting polynomials.